Okay, I can move that. Hi, I'm Berry, and this is my video about the large language model I made based off of this tutorial by Andre Karpathy called "Let's Build GPT from Scratch in Code Spelled Out." Um, Amazing video. I highly suggest giving it a watch. Back to this. So this is the GitHub page for it. Here is my, and here on the left here is my actual program. So these are a bunch of variables that kind of operate the model. Some key ones I'm going to talk about is max iters, this one, which is how many times is it going to run over the data. Right now I have it set to be 400 times. This is actually really small on the scale of large language models, but we'll kind of talk about how that has affected the model in a minute. So we have eval iters, which is how many times it prints out. As you can see, it prints out every 20 every 20 iterations. And then you have learning rate, which is just kind of how much will it correct itself during the training process. This is setting up the randomization of the model, and setting the seed of the model is making it consistently random. So it's like if you were to go rewrite what I have here, you could use the same seed and get the same results. Changing this would give a different output. This takes in the file, which takes in the training data, which in the case of this is just a bunch of Shakespeare, and there is a lot of it. It goes all the way down to 40,000 lines. A lot of data. And so, yeah, it's just a lot. And this section is setting up the vocabulary of the model. And so what this is doing is it's just getting all the unique characters or this right here gets all the unique characters in the training data and smacks it into a list and sorts that out. And what it does is, what these do is it defines how it's going to, it's defining how we're going to handle the data, which in this case is just converting the character to to its corresponding location in this list, which is essentially just giving a number to each letter. Now, having this vocabulary list is very important to the model, because a model can't train off of just straight up text. It has to have numbers in some capacity. It has to train off of numbers. And another thing is that knowing how much vocabulary there will be is important for how it's going to output everything, because the output isn't spitting out what will be the most likely, or it's not just saying this is what the next word will be. It's saying this is what I predict will likely be the next word in this text. Or in the case of this model, it's what will be the next letter of this text. or character. Like it could be space, it could be punctuation. That's what the model is going through and deciding. This section here splits up the training data and the validation data. So what does this mean? So it's splitting the text about around a 90% mark. So the last 10% of the data is used to validate. So what do those terms even mean? So the training data is what the model will actually be running through over and over again. The validation data is used to say, hey, stuff is used to check for stuff that may be outside of what uh, the model was trained on. Because if you run over training data so much, it could tight fit itself onto that training data. And so the validation data kind of helps indicate, hey, it may be conforming to the training data, but it may not be conforming to other forms of data. So we have a couple functions here. And these are the classes of the model. These are just all the parts of how the model works, all kind of working together to make it work. And then here is where we actually are setting up the model and having it run. Or no, this is where it's training, sorry. So this is the loop where it's going to go over all the iterations and iterations. So this is kind of like where it says, hey, it's going to print out at these spots. Yeah. And this is our learn function. This is where the learning rate comes into action. So this one we're just using a predefined learn function. So that's getting used and that's what's used to actually go back and fix the program. So this is where it's just calling the newly made program and having it kind of generate its own thing. So it uses m.generate. What this is just doing is it's going over and over the data, and we're just going over and over, putting out the new letter each and every time until it's hit this max where it'll end. So to kind of show an example of it is this little bit here. Now, of course, this doesn't look like English. Like, I don't think I've ever seen any of these words in my life before. But even though it's not producing like any actual English, you can start to kind of see you can kind of start seeing it developing language, because you can kind of see its formatting. You have spaces between a bunch of words, and you have like punctuation at the end of sentences. You have these strange names with the colons, kind of like how it is in the input for Shakespearean writing. Has all these indents here. So yeah, you can see it's kind of start developing this knack for how to write out language. It just doesn't, but obviously it doesn't know any of the words yet. So some adjustments that could be made to this to kind of help those would, first of all, be having it go through the data more, having it iterate more, having it's, they say practice makes perfect. And so having it go over it more and more is essentially like it practicing more and more. And Another thing that would make this much better, which is a lot more relevant in what'll be my next video, is that instead of it printing out just character by character, it's going to print out entire, I would say words, but that's not entirely accurate. It's how it will work, but that's something for another day. So I hope this has helped expand your knowledge of large language models, and the video sure expanded mine. So stay tuned for what's next.